Hello everyone. Okay, in the next 2 hours, what we are going to do is we are going to try all the variety of questions. So yeah, we are just starting. So if you got no problem, I will link this thing on the chat, the file. So if you got no problem, then jom kita start our trial Form 5 revision. Okay, so let's just start from our Form 5 Chapter 6, okay, which is nuclear. So in nuclear, usually, they will just ask a few different sections. Maybe sometimes they'll ask alpha, beta, gamma. But also recently, hot topic is in the nuclear fission and the nuclear fusion section. So nuclear fission, right? This one will relate to your nuclear reactor, which you need to know how they control the nuclear chain reaction. So this is one thing. Nuclear fusion, there's this thing whereby you have to heat this to high temperature to give it high kinetic energy. Why is it so? Because you want to overcome the electrical repulsion. So now when we look at this question, okay, so we have this direction of magnetic field inwards. Now they ask you, so what is Q? So as we can see, P is deflected up, R is deflected down, Q is not deflected. So meaning to say this has no charge. So when we write this, we will say gamma. Tetapi we have to write the full name. So gamma what? Gamma what? Yes, correct, gamma ray. Okay. Now remember, in physics, the very particular one. So there is such thing called alpha particle. If they ask you what is it, it's an alpha particle. We also call that as a beta particle. So they are all particle, but because gamma is an electromagnetic wave, so we call this as gamma ray. 对, yes, Ihan, correct. Now, next, so give reason why the path of emission is Q is straight, but P and R is curved. Okay, because why? Because Q has no charge, all right? And also then we look at why P and R is curved. P and R is curved because they have charge. Now, if you want to like make your answer sound a bit more convincing, because sometimes if you say, oh, because P and R has charge, some of the school teachers will say, oh, I cannot accept that because you never tell me what charge. So we try to be a bit more specific. Okay, we check this one first, P. So the P and R, which one is alpha, which one is beta? So we can see here, the one that go further. As you can see here, this thing obviously goes further, right? Like very much further, right? So means that it is heavier, means that it is less deflected. So this is alpha. So this one deflects more. Okay, we say wider angle of deflection, So therefore the R is known as beta particle. Okay, so we got alpha particle and we got beta particle. So in this case, we will just say that, okay, why? Because P alpha, beta, okay, sorry, okay. So in this case, okay, we say, instead of we say P and R both have charge, we will say P, because it is alpha, alpha is the positive charge, beta is the negative charge. So we can say because P has positive charge, whereas your R has negative charge. Okay, so therefore this is a better way of answering the thing lah. Okay, now next, if we just try to look here, okay, you guys know how to determine why P will go up and why R will go down, right? What is the rule? If exam asks you, what is the rule we use to determine why P go up, why R go down? So what is your answer? Yes, we have to use this thing called your Fleming's left-hand rule, okay? So remember, when your alpha keluar, okay, when your alpha keluar, alpha means that this is the same direction as your current. So meaning to say that cross means your magnetic field enter. So if you want to just try this very simple, okay, this is your Fleming's left-hand rule. We got this thing called force, magnetic field, and current. Father, mother, children, FMC. So if your magnetic field enter, cross means it moves away from you. So you see this thing, it goes away from me, right? Okay. So therefore, my current is moving to the right-hand side. So imagine you now take this gun, you shoot the person in front of you. Okay, you shoot the screen. You will see that your middle finger will point to the right-hand side. Okay. So you will see that also your force will go up. That's why alpha will deflect upwards. Okay, Ken? Now, lepas tu, Next step, if you look at the beta, beta means that beta is actually your electrode, fast-moving electrode. So when beta moves to the right-hand side, your current will move in the opposite direction. When your current moves in the opposite direction means that now you use your left hand, your magnetic field moving away from you, then your middle finger point to the left-hand side. It's just like how you see your watch. Okay, if you wear your watch on your left hand, then you see your watch. So you realize that your thumb will point downwards. So this is where your force will go down. So therefore, this is for you to find deflection of alpha, beta, and gamma. Okay, Ken, to find alpha, beta, and gamma punya deflection. Okay, so if you got no problem, then next we go and see question C. Guys, I've already posted the material in the chat. So next, complete this thing. So if we look at this calculation, this is how to write equation. We got 2, 3, 5, and 1. Here 92 and 1. So if we look at on the left hand side, this is 2, 3, 6. So this is total of 93. So therefore, what? Okay, but here there is a very common trick here. You will see that there is 3 moles of this neutron. So this is actually 92 plus 3. Okay, Ken? So this is a very common exam trick. They will put like, let's say, how many neutrons. So this is 3 neutrons. So now, how much is this one? So this should be 1, 4, 1. Okay, because it's just like mathematics. So you take 2, 3, 6, you minus away 95, you get 141 nuclear number. Settle now. Then we go and see this calculation. So in nuclear, there are 2 calculations. One is your half-life calculation. Second one is your E equals to mc square calculation. So half-life, these 2 pun kena tahu, both also you need to know. But this M, remember, for E equals to mc square, for the M, you need to be able to find mass defect. So mass defect, most of the time, you have to use the before punya mass minus away after punya mass. Okay, but luckily this question, they straight away give you the mass defect is this. Means sudah before minus after already. It's already minus already. So now if you want to calculate, what do you have to do? Very straightforward. You just have to do E equals to mc square. So my mass defect is 2.988 times 10 to the power of negative 28. Speed of light is 3 times 10 to the power of 8 square. So you will get your answer. Final answer is how much? Is in joules. So guys, time for question. How many decimal place do we need to write? Okay, so it's 3 decimal place. So 2.689 times 10 to the power of negative 11 joules. All right. So remember, guys, in nuclear, 2 calculation, half-life E equals to mc square. In the theory part, 2 theory part with your alpha, beta, gamma, and your fission, fusion related to nuclear reactor. Very important. All right. So 2 things. 2 theory, 2 calculation. Okay. Nuclear reactor, very important. So if you got no problem, lepas tu, we look at question number 2. Okay. Now here we have something known as a hydraulic system. Okay. So in a hydraulic system, we look at this one first. They want you to compare surface area of the syringe A with the piston of syringe B. So the first thing we have to compare is surface area. The second one is the force acting. And then after that, the pressure, and relate and name the principle of physics used. So there are a total of 5 questions here. Okay, there are a total of 5 questions here. So usually 5 marks, my strategy is we try to identify the 5 questions in the question. First one is surface area. Second one is force acting. The third one is compare the pressure. The fourth one is surface area. Fifth one is principle of physics. All right. So let's do this together. The surface area of the piston. So we can say the first one is what? Your surface area of the piston in A is what? Smaller or lower than the surface area in B. Okay, so this one very important. Don't use the A smaller than B. Guys, I know a lot of school teachers sampai hari ini still insist student to use A, B like that, okay? But I can give you an evidence. You check recently 2022 punya state paper, most of the answer in state paper already became sentences already. Last time, if you look at 2016, 2017, still got A smaller than B. But now, try to use sentences, I remember, okay? Now, so number 2, okay, so we compare this one small, big, okay? Next, we will compare the force. So which one produces more force? So hydraulic system is small force masuk, then big force keluar, correct? So we can say that the force in A is lower or smaller force also boleh, all right? Lower force, smaller force. Then after that, then the force acting on the piston B. So A lower than B, A smaller than B also can. Then we look at question number 3. At question number 3, you will see the pressure on the surface. So now we talk about this. So pressure, A and B, which pressure higher? So in this case, because this is Pascal, okay? Remember, Pascal, you see, this is P. P stands for pressure. P pressure. So Pascal punya principle, PP, Pascal principle is pressure the same. So therefore, we must say that the pressure at point A is the same as the pressure at part B like that. So A is the same as pressure in B. So macam tu lah. Okay, Ken? All right. Now, number 4. So at point number 4, you will realize that we got relate. So remember, your Form 5, right? Relate, you tell, right? We have to write the higher, the lower, or the higher, the higher, the higher. There's no directly proportional, no anything. So we can say the larger the surface area. All right, because you see, A has smaller area, so A have lower force. B have larger area, so larger force. So the larger the surface area, the larger or the higher the force. So macam tu, okay? You will see that this 5 marks, guys, is the simplest 5 marks in your exam paper. So if today you are, let's say, a 50 mark student, this 5 marks is your free marks, okay, Ken? The greater the force, the larger the force, boleh, okay? The greater the force, the larger the force, Ken. Okay, so therefore, this is, the last one is named the principle of physics, so it's Pascal's principle. All right, Pascal's principle. All right, so done liao. So this is how you get your 5 marks. Very simple. Okay, once we are done with this thing, okay, we go and see a chair for dental treatment. So this is going to be one of the example where they say, how do we explain how this chair is being lifted up? Okay, so usually how we say this chair is being lifted up is we'll just say like how this principle works. So it could be a chair, it could be how to lift a car, it could be it could be Pascal, everything related to hydraulic system lah. Okay, so what can we say here? How this chair can be lifted up? So number 1, we can say a small force is acted on the small piston. Okay, you want to say a small input force, because this is the force that you push into the piston. So what you do here is you actually press or step this thing. Okay, so inside here there is a fluid, then you got the bigger piston. A small force is acted on the small piston, so we can say due to small area of piston, then you can say a very large pressure is created, or you can say is transmitted. Lepas tu, we can say here, according to Pascal principle. Guys, I suggest you to write because tomorrow, tomorrow, punya 24 hours later, this is your exam already. I mean, for those Selangor people. So according to Pascal principle, what happens? We can say the equal pressure is transmitted in all directions, or you can say towards the big piston. All right, so the first part is I push a small force, because now you have to say how can be lifted up. Then I can say because it's a small area, so large pressure is created. Then after that, what happens? Because Pascal principle, so your pressure is transmitted equally. You can tukar pressure is transmitted equally in all directions, or equal pressure is transmitted in all directions towards the bigger piston. Okay, last part. So now I just have to focus on the bigger force. So larger surface area at big piston, the larger surface area at the big piston produces larger force. You can say it produces larger force that can lift what do they call a chair. They never say dentist chair, so just keep it as chair. They can lift chair up. So the larger surface area of big piston produces a larger force that can lift the chair up. Alright, hopefully my word is not too ugly. Hopefully my sign is not too ugly. Can Okay, usually they also use another name punya. Okay. Now the masuk piston, they will usually call it as the master piston. This one they usually call it as a slave piston. But here, then got people ask me, teacher, what can I refer master and slave piston? Cannot. Okay, why? Because most of the time, your schema jawapan will be based on the picture. So if they say big piston, you write big piston. If they say large piston, you write large piston. So whenever I use back the word, okay guys, these are all answering technique, like answering technique. So therefore, this is small piston, big piston. So I follow back the word. Okay, small piston, big piston, large piston. Can Boleh okay. So once we are done with this thing, okay, then we will continue and see the next part. All right, now like this one. So here we got a hydraulic brake system in a car. So here we got this whole entire thing. This is a 10 marks essay. So this is like you have to write lah. So based on here, you have to say the properties of the brake fluid, the size of the pistons, and the material used for the transmission pipe. Okay. So 5 EC, 5 explanation, 10 marks. Okay, so let's write this together. All right, guys, am I too fast? No, right? Okay, so I'm too fast. All right, because you slow. Okay, so okay, this one faster. I give you 10 more seconds. Okay. So done. Okay, done. Next. Okay, we see. So now we're going to talk about the brake fluid first. All right. Okay. So usually brake fluid, what are the characteristics first? So let's just think about what kind of things that usually we can say brake fluid. So number one, brake fluid is what? We usually want what? High boiling point. Okay. Remember, recently there's this trend. Trend as in they would like to say you must have a lower rate of boiling point. High boiling point means that it can be heated to a high temperature. Low rate means how fast it reaches the boiling point. So we want lower rate of boiling point. So this light blue color is the issue semasa. Okay. Selain daripada itu, there's more. So one very important thing. Who can tell me? Okay, the third one is I know what people tell me this one. So you want low density so that it is lighter, lower mass, and so on. Okay. Now we will try to avoid writing high viscosity. High viscosity is correct, not wrong. But the better word here is we can say it has to be incompressible. Hello, korang dah lupa ni ke? Incompressible, or we can say that it will not form air bubble. Actually, these two answers got a bit 重叠 lah, but yeah, incompressible. It will not form air bubble. Because if your liquid is compressible, then the pressure transmitted will be lesser. So make sure you remember this. I think the first and second one is very important. Alright, okay. Later we'll write together, don't worry. So here, piston, I got dua isi already. I say that the in must be small, the out must be big, and the type of material used for the transmission pipe. Okay, usually type of material, I don't have to write a lot. I'll just write one type of material. So usually this material, we will use what? We can say steel. So why do we want steel? So steel has a few advantages. One is stronger law. Then you can say it will not rust law and so on. Because this one is inside, it has to tahan the pressure that is transmitted. Because don't forget, for a hydraulic system is macam ni leh. So you have this thing. So when you press your pressure here, you will get equal pressure, right? And guess what? The pressure that's transmitted is going to be very, 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 very high, right? So if you transmit like literally very high pressure to all the walls, so this thing will actually cause the wall to break. So you need a stronger material to tahan so that the wall won't break. All right. Okay, so let's write this together. Okay, so step one, we will talk about the properties of the brake fluid. So number one, we will say that what we want here is we want higher boiling point. So example, so alloy, I guess it's acceptable. Okay. Now, so in this case, a higher boiling point, what is the advantage? So usually, guys, this era now, a lot of teachers sudah ban easily, this word, the word easily. Because easily is a very 2018 kind of thing. Now, punya new trend is they will say, if can, try to avoid easily. So rather than I say high boiling point, it will not evaporate easily. I can say that a higher boiling point means that it will be able to reach higher temperature. Okay, it can reach higher temperature without evaporating. So bermaksud that you can heat it to, let's say a high boiling point substance means you can heat to that temperature, but it doesn't evaporate. So let's say, for example, oil. So what's the advantage of oil? If let's say in Malaysia, if one day the weather very hot, if your hydraulic system is water, your water will have evaporated, but oil will not evaporate because it can reach higher temperature. All right. Then next, we write incompressible. I will follow back the incompressible. Incompressible. Okay, why? Because incompressible, the not volatile. Kelly, you mean here, right? For example, here, not volatile. Okay, I think volatile and okay, my chemistry not very good lah. Okay, volatile and evaporation is something like the same meaning. I get volatile is like it will evaporate at room temperature, but I think if you think like which is in the schema, I think evaporation, the word evaporate is higher chance to come up in the schema, which means that they will match the schema. So if you ask me evaporating and volatile, I would say evaporation is a better answer. Because volatile means like room temperature, then it will evaporate. So that means that it's too low. Okay, can Now, so okay, incompressible. So incompressible means that if I squeeze this in, okay, I want the pressure somewhere to go there. If this is compressible, meaning to say that my liquid pressure will decrease. If my liquid pressure will decrease means that something sounds wrong, right? Because your liquid, not your liquid pressure, sorry, your liquid volume will decrease. Your liquid will get lesser. So you press this one, the water become lesser, but this thing won't go up. So it has to be incompressible so that the oops, so that the pressure can be transmitted equally to the larger piston. Okay, so your pressure can be transmitted equally to the larger piston. So this is the aim now, so-called. All right, Ken. Now, guys, people who came in late. Now, there you go. Okay, the third one. Okay, so the third one, right? I'm just gonna go very fast because for the third one, we got this thing called the small input piston here, or they say master piston. So what do? We follow back small input ataupun in this case we follow back the question so we say small master piston. Remember, guys, whatever answer that you write, it will be matched based on the picture that they give you. All right, sometimes we call master, sometimes we call input, sometimes we even call it as primary piston. So whatever you write, we match back the top so small master input piston. So kenapa? To produce higher pressure to be transmitted to the larger piston. Remember, a lot of teachers, right, actually get confused over this thing, whereby we never put small and the why do you want to have a larger area of, okay, see the second piston. So they never use the word slave. So don't use slave lah. They say second piston, then you equate the word Remember, small master input, small area of the master input piston, the explanation, and the larger area of the second piston, meaning to say that your masuk and keluar area is not the same. Remember, the explanation is different. A lot of people thought that it's the same. No, it's different. The input is to produce pressure. The area output is so that a larger force can be created to, okay, in this question, you can just say produce a larger force can be created to, so here to probably stop the car, to brake. So can be a larger force can be created to brake, because this is a hydraulic brake. So one is higher pressure, the other one is higher force. Jawapan is langsung tak sama lah. Okay And last but not least, material. Is using oil. Yeah, Ming-Shui, correct. So therefore, then after that, the last one is we will usually use steel. Okay, or alloy also can. Why? Because it's stronger, can withstand high pressure transmitted in transmission time. So this is very strong, so it can withstand the high pressure because you're going to squeeze it, so the pressure inside is going to be very strong. Okay, can? All right. Boleh 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 Okay. Now, next, let's look at question number 3. Okay, I give you all 10 more seconds. Okay, time's up. Next. Okay, so question number 3. So this is a cathode ray tube. So cathode ray tube got 2 types of deflection punya pattern. Got 2 types of deflection pattern. So type number 1 is electric field. So they use VLT, electric field. And type number 2 is they will use the magnetic field, which is they use north-south magnet. All right. So you have to be ready to face both of the question. All right. Now, so let's see the first one. So here they say when switch 1 S1 is closed, all right. So the electrons are emitted from the cathode. So what is this process called? This process is known as thermionic emission. Thermionic emission. Okay. Now, so we tengok here. Okay, you guys know what is the difference of purpose now? You see, here got extreme high tension, 1.5 kilovolt. Here got 2 kilovolt. Then here got 6 volt. Do you know what is the difference in these three? Like, why do you need the 6? Why do you need the 1.5? Why do you need the 2? Okay. Usually, this 1.5 is the positive one that will pull your electron forward. So the purpose of this is to accelerate your cathode ray or your anode. All right. This is the positive, which will cause your cathode ray to deflect. Okay, why? Because your cathode ray is electron. So this is to do deflection. So there is a difference. You don't 搞错. Then this one is for you to heat up the cathode so that you will have thermionic emission. So the purpose you have to understand. All right, not like 死背 now. Okay. Now, why is this very important? Okay, why is this very important? Why knowing this thing is very important? Okay, because you see the next question, this part B here. So they tell you that the electrons move towards the anode. So let's say now they want you to calculate the maximum velocity of the electron. Okay, so I'm going to write my working here. Calculate maximum velocity. So in this case, I don't like to use the formula that is given, which is the what V2 EV over M. Too confusing for me. For me, I prefer to know what is the energy change. So when this thing is finding maximum velocity, it is accelerated. Means finally the energy will become kinetic energy. So from what energy? This thing called electrical potential energy to become kinetic energy. So your electrical potential energy, kinetic energy is half mv squared. So this one you don't have to worry. You just have to go and see your formula sheet. Okay. Now I have something like the official formula sheet for SPM, something like official like that. So if you look at the formula, they actually gave you something like this one. Boom. Electrical potential energy. So this is like the official one. Okay. So if there is an electrical potential energy, mark so that I don't have to force myself to memorize it already. So this is just going to be EV. So you got EV equals to half mv squared. So this E is my electron. So 1.6 times 10 to the power of negative 19. This electron, they gave me 1.6 times 10 19 called charge. So then after that, voltage. Then after that, half 9.111 or 9.11 times 10 to the power of negative 31 V squared. All right. Now, so why this question here very tricky? Because the trick is this. When you look at this thing, you don't know to use 1.52 kilovolt or 6 volt. So here right now, if you understand my purpose, so do we use the 1.5 or the 2.0 or the 6 volt? Yeah, so you know that because this is the one that the job is to accelerate it. So therefore, this is going to be 1,500. Okay, so here my velocity will be equals to pilipala meter per second. Okay, so I don't know how much is this, but I think it should be something like 2.0 295 times 10 to the power of 7 meter per second. All right, can 2.295 times 10 to the power of 7 meter per second. Boleh? Okay, so once we are done with this, so the 2 marks settled already, okay. Now, make sure you guys know how to see the magnetic field deflection. Okay, why? Because this one is actually related to, okay, what is this related to? Your magnetic field, this thing is related to the Fleming's left-hand rule again. So after looking at your Fleming's left-hand rule, it also related to this thing called the Maltese cross tube. So there's a Fleming's left-hand rule, then related to Maltese cross tube also. All right, Ken? So the idea is this, okay, Ken? Now, anybody got any problem? Okay, if you got no problem, then we continue. Okay, so here we got the path of cathode ray in a deflection. Complete the path of cathode ray. So what happens to the path of cathode ray when the value of EHT increases? So when the value of EHT increases, what will happen? Oh wait, sorry, I haven't drawn. Okay, so will deflect upwards. So macam tu lah. So what will happen if I increase my EHT, guys? Yeah, very simple. The answer will be larger deflection. Okay, usually why a lot of people do not very good in physics is because of this problem. Okay, so what larger deflection was settled. Okay, so why? In this case, how you explain for the second mark is very important. Okay, I'm very interested to hear. Okay, if this thing comes out in your exam, how will you explain this thing? Why, if you have a higher value of EHT, you will have more deflection? Okay, the only answer is more proton. No. Okay, a lot of people say are more positive. No, you just have to keep it to this thing that you learned before. Stronger electric field. Or you can say electric field strength increases. Okay, can, all right. Yeah. All right, can strong electric field strength. So therefore, then you can also say so that it is if you want electric field strength increases, so therefore there is attraction force. Understand? Okay, next. Come on, guys. Let's go and see the next question. Okay, so question number 4. Here we have your 1.5 volt, 1.5 volt, then this one is 1.5 volt, 1.5 volt series and parallel. So in this case, what's the meaning of 1.5 volt label on the battery? Okay, actually, right, when they ask this question, do you know what is the what definition are they asking for? So you see here, 1.5 is the what? Yes, very good. It's the EMF. 1.5 volt is the EMF. So this definition, they're actually asking you the definition of EMF. So in this case, we can say when you have 1.5 volt, volt is work done per unit charge, energy, joules per column kan, energy per charge, right? So here we can just make it very simple. We can say that this is because you have 1.5 joules of energy, all right, is needed. Okay, because it's joules per column, to move what? Per column of charge, right, is needed to, first you have to say by an electrical source. So who is the electrical source here? In this case, is the battery, all right? Or you can say by the battery also can. by the electrical source to move one column of charge, all right, 1 coulomb column. Okay, then still got one. The belakang still got one. If it's potential difference, then very simple one. But now you must say in a complete circuit. Okay, can? So this one important. Kenapa important? Because why is it important? Because complete circuit means that is the total EMF. EMF is including the outside and the inside of your battery. Okay, so therefore that's the idea of it. Okay, then next. So we will compare the arrangement of batteries. So 5.1 is, let me check 5.1 some more. 5.1 is in series, 5.2 is in parallel. So this one, right, when you compare, you cannot say 5.1 is higher than 5.2. You can only say the diagram 5.1 battery is arranged in series, 5.2 is arranged in parallel. Then which one got more EMF? So the total EMF in diagram 5.1 is higher than diagram 5.2. Higher, greater. Then what about the gradient of the graph? Okay. So here we got one problem. Okay, can anybody tell me my gradient of this graph represents what? Okay, this VI graph, Jung Hao said before, very special one. Why? Because this VI graph is going down. So usually your y-intercept is what? Usually your y-intercept is actually your EMF. This is your EMF. Your gradient is, to be specific, is called internal resistance. If you write resistance is wrong, confirm wrong. Okay? Yeah, so you must 讲好 it's internal resistance of the battery. Okay, that's the only acceptable answer. So therefore, if we compare the gradient, obviously you can say the gradient in 5.1 is steeper, greater than diagram 5.2. Okay? Okay, next. So this one, okay guys, you just write ... If you are writing this with me together, okay, you can just write ... no problem punya. Okay, next. So it says here, what's the total electromotive force of the battery? So if we have total EMF of the battery, if you are asking for the total EMF of the battery, comparing with the arrangement, how to write this? Because biasanya we can write the higher, the lower, the higher. But this one is how? So this one, it has to be something, this relationship, you have to compare. Yes, so you must say, when the battery is arranged in series, the total EMF is greater than when battery is arranged in parallel. So it's something like a comparison punya ta'an. So when the battery is arranged in series, the EMF is greater. Guys, remember, okay, Trish, do you know how I know this or not? Do you know how I know this answer or not? The answer is I don't need to know. I just have to look at the question. Is this series? 3. Then if it's parallel, 1.5. So I think this is pretty much self-explanatory. Okay. So after we can also compare the gradient of the graph. So if it's when the battery is arranged in series, your gradient of the graph is steeper than when in parallel. So this is why I selected this question to do on such an important day, is because this comparison relationship is a bit more special compared to other things, compared to other questions. So this is a bit more special. Okay. Okay, next. Then we will look at the electrical circuit. All right, the next one, part donkey. So here we're gonna do our calculation. So they give you a bunch of information. So this one very straightforward. This 6 volt is obviously the EMF. So next we will see E is equals to V plus IR. Now, Jung Hao punya style is I use this. I don't use the IR plus IR. Now, why? Because most of the time they will give you, if the potential difference across the resistor R is 5.8 volt, if the potential difference across R is 5.8 volt, you will realize that 5.8 volts is actually this V. So I can actually use this V equals to IR. This V is 5.8. Your current is 0.5 R. So my R, if I shift over, it will be what? 11.6. Big R, right? They don't need me to find big R. Why am I calculating the big R? Sorry, very, very used to this kind of question already. So therefore, is this a 6? This is 5.8 plus 0.5 small r. Lagi easy, this one. So therefore, how much is my answer? So this one R will be equals to 0.4. So I can actually find small r, I can actually find big R. So both. Yeah, sorry, I just realized that one internal resistance. Too easy already, guys, this kind of question. Okay. As you remember, when you look at your state paper, biasanya your state paper is considered the easy version. I tell you, KBAT state paper is harder. So unless anybody here is from KBAT, otherwise, I don't think there's anything very, very complicated. Okay, Ken? Now, if the above circuit is used for a longer time, what will happen to the value of internal resistance R of the battery? Okay, if your battery used for very long, guys, what do you think will affect or happen to the internal resistance? So the longer you use your battery, the more efficient or the less efficient? Less efficient, right? So so what means that the value of your internal resistance of the battery will increases. So it technically increases the internal resistance, so means that it will be least efficient. Okay, Ken? All right. So therefore, this one is usually like this. Guys, make sure you know how to calculate series parallel. Series parallel. Okay, Ken? All right. Now, if you got no problem, okay, then we go and see page 13. All right, page 13. Next one. Here they give you a bunch of international space station, solar electricity, blah, 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 blah. Then they ask you what is a photoelectric effect. Okay. So, what is photoelectric effect? Okay, so photoelectric effect and your thermionic emission is like abang adik one. Okay, why? Because thermionic emission is you give heat. If you talk about photoelectric effect, what do you give? You give light. Okay, or you can say photon lah. Okay. All right, okay, light or photon. So what's meant by photoelectric effect? This one definition or don't play. So we can say it is the release of photoelectrons. Okay. Now what although we throw electron, okay? Biasanya we throw electron. No, because this is photoelectric effect. Andrew, I think your answer that one is the definition of photon. This is photoelectric effect, the whole effect. So it's the release of photoelectrons. Walaupun most of the time you can call this as electron. Okay, but I prefer to call it photoelectron because textbook write photoelectron. So I follow textbook. All right, photoelectrons from metal, okay, when light with sufficient, some they will say higher frequency or sufficient frequency or whatever. Okay, when a certain or sufficient or yeah, they always also write certain frequency shines on it. It's a release of photoelectrons from metal when light with certain frequency shines on it. Okay, guys, here I miss out one very important. No matter in thermodynamic emission, no matter in photoelectric effect, it's always the same word. If you don't say the right part, wrong lah, Trishan, of course lah. Okay, because what causes the photoelectron? So the answer here is people always don't say metal surface. Okay, can it's always metal surface. Metal surface. Alright, can boleh? Okay, not bad. Okay, guys. Now, did Jung Hao fail you or not? Okay, did I fail all my students? Is by looking at part B, guys. If your part B jawapan correct, then I think I did a good job. If my part B jawapan wrong, then I mean if you get this part B wrong, then okay, GG. So does the increase in light intensity increase the kinetic energy of the photoelectron? Yes or no? Explain your answer. Okay, so in this case, okay, because we say already, intensity is different. Okay, now first of all, kinetic energy keluar, right? Correct. This thing comes out is your what? Your photon energy. Your photon energy is what? HF. F will affect your kinetic energy. Okay, then I test you. If okay, the answer is no, guys. The answer is no. Then light intensity affect what? Okay, so we can say kinetic energy, number of photoelectron emitted. Okay. So yeah, kinetic energy is affected by frequency of light. Okay, your light intensity. Okay, guys, light intensity, right, is like how much light, how many light, correct? So light intensity affect what? The number of photoelectrons emitted. If you have more light, then you will have more photoelectron. Okay? Can I? Okay. Next, okay. Now, so sketch a graph to show the relationship between the maximum kinetic energy of photoelectrons and the frequency of light shown on the metal. Okay, kita tengok properly. Okay, so what we can see here is you will see that okay, this is the whole entire graph. So this is K max, and then this is the frequency shown on the metal. Okay, how does this graph look like? Okay, so sometimes you can use this kind of like cacat way to determine okay, if you forget Now, because according to Jung Hao punya strategy, HF work function keluar kinetic energy, correct? So our equation very simple is HF minus work equals to kinetic. Guys, I don't like all the like what half mv square HF blah 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 blah, very confusing. I just keep it very simple like that. So according to my y equals to mx plus e, this is my y equals to mx plus c. So I know that I have a negative y-intercept. So I get something like this. I get something like this. Then after that, so this is my negative work function. This is my gradient is actually my Planck constant because m is h. So this is how we look at our graph. Schedule relationship between my schedule selections. Yeah, done. Okay. Okay, 2 marks only. Next, we go to part D, photoelectric effect. Okay, guys. Now I know that if now you are still very panicked over all this like quantum physics, I think sekurang-kurangnya, guys, you try to solve two things first. You try to solve photoelectric effect, and if can, you try to solve your de Broglie wavelength first. Those are the things you have to worry first. Other, you don't worry first. 不一样啊 Planck constant is your H, de Broglie wavelength is the lambda, which is the H over mv momentum. That one is to find the the particle one. Like, 其实 you all change the wave to particle, the wavelength. Yeah, so it's a different thing. Okay. Now, so okay, this question, if you look at this question, it's a package. It is 4 marks. So if this thing come out, usually they will come out together. All right. So you have to understand how this thing works. Okay. So we see here, when there's a matter with a work function, what is the maximum kinetic of the emitted photoelectron? Okay. So here got two problems. Number one, we have to know what is all the terms first. So work function 2 eV is the work function, okay, which is Junghao style is called price tag. Masuk punya is my HF. But then usually in an exam, they like to kacau you this thing, whereby they don't give you the frequency, they give you this thing, the lambda. All right, okay. So bermaksud that selain daripada HF, I can also make this to become something what we call HC over lambda. All right. Now we can actually derive this because C is equals to F lambda because V is equals to F lambda. All right. Now, but then if you look at this question, guys, they never give me C. How to find C? Because in exam, when you look at this question, there's no C. Then how? Do I need to memorize C? Now, the answer is in front always will give you this bunch of things, okay? Yes, formula paper, okay? This is why you need to start to like familiarize yourself sikit dengan formula. In fact, the HC over lambda, they also give you already one. HFF is C over lambda, so HC over lambda. Do here? Yeah, so actually, for the belakang chapter punya calculation, they give you very detailed already. In fact, they even give you Planck constant, they give you all these things already. So formula paper, very important. You need to agak-agak know what the formula paper is like. Okay, you agak-agak need to know what the formula paper is like. All right, Ken? Now, so here, okay, let's start. So here we got HC over lambda. So this is what I want to settle dulu. This is my energy, HC over lambda. So my Planck constant, 6.63 times 10 to the power of 34. So speed of light is going to be 3 times 10 to the power of 8. Tadi I in front get ready. So now the lambda 4 for -7. This is considered quite kind because sometimes they'll give you like what 700 nanometer dan sebagainya. They'll give you in terms of nano. So when they give you in terms of, let's say, nano, it's even more headache because you have to change it to the nano, micro, milli, all the blah 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 stuff lah. Okay. So therefore, next you will see here. Okay. We have this thing. So how much is this? Okay, I don't know. Can any kind so help me to calculate? This is in terms of joules. 4.973 times 10 to the power of -19 joules. Okay, so this is the one masuk already. Okay, but what about this EV? Okay, this EV a bit leceh. Okay, you need to know that this is actually the charge of electron. Your your E is actually the charge of electron. Okay, so this one sepatutnya they need to give you. This one actually sepatutnya you don't have to memorize. So this one is their mistake. They never give you this thing. All right. So now, okay, 2 EV, I want to change it to joules. Is I have to times 10 to the power -19. So I get 3.10 to the power -19 joules. So this is in terms of joule. So how can I find what is the kinetic energy that keluar? So I have to take this. This is in. This is your price. This is your out, which is kinetic energy. So we will take 4.973 times 10 to the power of negative 19. Tolak 3.2 times 10 to the power of negative 19. So I'll get my final answer to be equals to 1.773 times 10 to the power of negative 19 joules. Okay, Ken? All right. 2 marks. Good. Actually, I think this question deserves 3 marks. In my opinion, I think this question deserves 3 marks. Oh yeah, Ken, all right. Okay, next. Guys, in fact, I want to do faster, guys. Bukan sahaja fast. I want to even do faster. Alright, due to time constraint. Okay, so I'm going to do even faster. Okay, next. So we're going to look at the next question here. Calculate the maximum velocity. So now this is B boy. B student. Okay, so therefore, this is your kinetic energy. Kinetic energy equals to half mv squared. Okay, so kinetic energy is 1.773 times 10 to the power of negative 19. So this is going to be equals to half mass is 9.11 times 10 to the power of negative 31. Then this is v squared, so velocity squared. So this one you just have to calculate out the velocity to be blah 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 meter per second. Itu saja, guys. That's it. Very how to say? Very straightforward. Oh yeah, can. So usually, guys, you are very worried about quantum physics. I give you a hint. The only thing that you have to worry about quantum physics is photoelectric effect. Dulu. Okay, photoelectric effect dulu. Alright, Ken? Okay, so I'll skip if you downloaded the material, guys. If you downloaded the material just now. Okay, if you downloaded the material just now. The next part is we are going to look at I will skip a few questions. Then I will look at this thing, which is on question number 8. All right, I think we maximum can do 3 more questions only. Okay, guys, by the way, whatever I do today has no relation one. Okay, no, meaning to say I do random one. I do random stuff. Okay, can now. If you got no problem, okay, then jom kita start. Now, question number 8 here talks about this thing on a dynamo. So dynamo, everything. Okay. So what takes place in the dynamo? So it's usually when you ride your bicycle, because it's that bicycle dynamo. So usually is your kinetic energy become electrical energy. Okay. Do I need to write light energy? No need, because they want dynamo. It's not the light bulb, it's just the dynamo. Okay, Ken? So what is this physics concept known as? So we call this is actually known as electromagnetic induction. This is electromagnetic induction. All right, Ken? Okay, then we go to the next page, which is page 21. Here, this is a girl cycling at night, a bit dim, although the girl is already cycling faster. So what can I do to change this thing, guys? Anybody? Okay, I see all these people like to memorize jawapan one. Hey, Jiahao, this one is not the radial magnet 什么了哦, not concave. This one is not the normal that you see 了哦. So in this case here, the magnet here, because this is cycling, I want to increase the brightness. So oleh itu here, I can say use stronger magnet. Okay. Now di sini that is a problem. Okay, guys. Why I say, okay, why we very pantang this thing? Guys, I told you all before, from the beginning, when we say this sentence, there is always a bug. What is the bug here? Correct. The answer is stronger permanent magnet. Why permanent magnet? Because got electromagnet, got permanent magnet. Important or not? Nah, I don't want to say lah. You tengok. They actually even say permanent magnet here. That's why they also use the word. So you follow back. Use stronger permanent magnet. Okay, why? Stronger permanent magnet got what advantage? So it will produce more magnetic field lines, or you can say produce more magnetic flux. So therefore, higher induced EMF can be produced. Okay, or you can say more induced current. Okay, why you want a higher number or more higher number of turns of coil? Why? Very simple. Yes, correct. Because you want to have a higher rate of change of magnetic flux. Okay, rate of change means how to say cutting lah. Change and cutting is the same meaning. Okay, so to produce more induced EMF and induced current lah. All right, Ken. Okay, then what about suitable material? So the answer here we can say copper. Why? Because lower resistivity, so therefore lower resistance, so more current can flow. Okay, Ken. So higher induced current. Okay, Ken. Usually you need to be able to state all this stuff. State all this stuff. Okay, Ken. All right. So yes, correct for it. That is the idea. Okay, next. Okay, guys. We see here. Okay, this question, right, a bit weird, okay, but if with a bit of help, it becomes not very weird. Okay. Now they purposely give you a weird circuit here. So what's the purpose? Is they want you to know that the current is gonna go this way, then this one will keluar. So this is the direction of my current. Okay, Ken? Now, so if I look at this thing, okay, if I look at this thing, the top part is North Pole or South Pole? The top part is North Pole or South Pole? The answer is, well, everybody very good. Only got one person wrong. Okay. We don't know who's the person wrong, but one person wrong on it. The answer is South Pole. Why? Because grip rule. Okay. Grip rule means your finger go down, right? Okay, imagine guys. This one means your finger. Okay, imagine you grip your pencil. So your right hand grip rule, you put your thumb go down. You see that your finger following this direction. Remember, guys, you have to see like this. So your finger goes towards the left hand side. Alright, so your thumb goes down. Okay, if this is South Pole, usually this is North Pole, means it is opposite one. Okay, the problem is here they never tell you this is North Pole. Itulah masalahnya. Okay. So if my wire is now if now my conductor is at rest, okay, so this thing, now this teras besi move up, where will my current be? This one is like very, very weird. This question is like very, very weird, but it's special. Okay, now guys, if I move my iron core upwards, this also means that I move my wire. Also means that I move my wire downwards. Correct or not? Correct or not, guys? If I move my core upwards, this also means that I move my wire downwards. Correct or not? Correct. Okay. So now if you use your right hand Fleming rule, okay, you will realize that the current will move this direction. Okay. So this is where my wire is moved, because teras besi, your iron core move up means your wire go down. Okay. Imagine a bit, okay? If you're watching this video, you pause, you imagine first. So you take your right hand Fleming rule. Okay. Now here, okay, the red color part all understand already, right? So now when my iron core move up, means that my conductor move down. Okay. If my conductor move down, because if your iron core move up means it's going to go down, go down then itself. 什么意思? No. This one you have to use your Fleming's right hander. Because this is you cut. Alright. Say before already, the cutting is always Fleming right hand rule. Okay. We have讲过多次 this one. Yeah. How you determine the south pole? Which one? This one? Okay, this one is your right hand grip rule. Okay, grip rule. Do your right hand grip rule, your 拇指 is north pole, this is your south pole. Means this is north pole, this is south pole. So when you grip down, then the top part is south pole, your thumb is north pole. Okay, grip rule, north pole 在上面 up, south pole is at the bottom. So you go down. Yeah. Okay, can Alright. Usually this kind of right hand, left hand Fleming rule. Okay, I tell you guys, online student all very bad one. You know why? Because the problem is at home, guys. I don't believe when you learn this chapter, right, at home as an online student, I don't believe you will really use your hand and check. Exam come that time you will but the first time when you learn, right, let's say for example in June, July, right, you sure will do it, you just listen only. Okay, left hand, okay, right hand. So if you don't really like use your finger, you never get it on. Okay. Now, so Fleming right hand rule again, so north pole to south pole. So your gun must point towards the left hand side. Your thumb goes down, means you now right hand look at your watch. Right hand look at your watch. Then after that, this is your direction of current. Yeah, can all right. Okay, you write this direction first, you slowly do it later yourself. Okay, because no time yet. All right. Right hand Fleming rule. Right hand Fleming rule. Right hand Fleming rule. Which direction of current, the red one or the orange one? Guys, come on this one, right? In my Google Classroom YouTube got one. Okay, so if you continue to ask, right, means you expose yourself that you didn't watch. Okay. Now, so next. Okay, we continue to go and see page 24. Okay, here. So this is how a fish can be cooked by using a steamer. Explain the process. So how does a steaming process work? Okay, guys, don't forget these are 4 marks. So this is not like a chin cai, you do this, then you got answer already. So what is the 4 marks here? Okay, so first thing is we have to say, the first step is don't rush with the condensation. Yes, okay, we can say that the number 1, we can say that the water will absorb heat and absorb heat and evaporate. Okay, now in this answer, how can I make this answer lebih atas? How to make this answer lebih wow? Yes, correct. Absorbs latent heat here. So it absorbs latent heat for behind of vaporization. Okay, can? Fusion. Oh yeah, fusion. Okay, latent heat of vaporization. So, and evaporate. Number 2. So, if it absorbs latent heat of vaporization and evaporates, then we can say that the steam moves up to form steam, okay, or water to form steam. So the steam will actually moves up, and is trapped and condenses on surface of fish. So it moves up and trap. So instead of your steam can go out, so now this steam it will something like bounce back. Keyword condenses. Keyword evaporate. So the third thing baru, we then only go and say the condensation releases large amount of latent heat of vaporization. It releases large amount of latent vaporization to the fish. The process that actually cooks the fish is the condensation. All right. Lepas tu we go to point number 4. We go to point number 4. Baru kita cakap so that the fish can be cooked in a short period of time. Okay, the fish can be cooked in a short period of time. So therefore, that's it. That's how the steaming process works. By the way, guys, steaming is faster than boiling. So if you steam a fish versus you boil a fish, steaming will cook faster compared to boiling. What? Why not? Okay, I can. All right. Okay, next. We go page 24. Why steam has higher temperature than water? Of course, what? Okay, I ask you. Simply, if water at 120 degrees Celsius, this statement got 毛病 or not? Yeah, lor. Because this will become steam already, that's why steam of course higher temperature than water. Yeah. Okay, now next. Yep. Okay, next we continue. Okay, using the knowledge of heat exposure, you can use something to design a pressure cooker which can cook food in a shorter time, easy to handle and safe, won't explode. So explain your suggestion. Okay. Alright, okay, now guys, think about the pressure cooker. I know some of you are still copying this thing. God, Mingxuan, Google Classroom. Oh, Google Classroom, electronics, 有你给我生吞啊！我跟你讲啊，华健，Mingxuan say don't have transistor video, got or not? He said he don't know also. Never mind. It's okay. Dome shape cannot. Now guys, okay, for people who are in my Google Classroom, okay, okay, let's just okay, let me pause this thing first. Okay. Zoom recording. Thank you, Yishun. Okay, now so in this case, let's go back and see this pressure cooker. So for this pressure cooker, right, guys, what can we say to allow it to cook food and so on and so forth? Okay, can. So you can say the base of the material must have low specific heat capacity. All right. Now, how can we say why low specific heat capacity? Yeah, I don't want to say hot easily. So I can say it becomes hot faster. Instead of easily, I use the word faster to tie it, all right, to replace. So low specific capacity, it becomes hot faster or becomes hot in a short period of time. Lesser energy is needed for it to become hot. Okay, we got people say must be airtight. How do you airtight it? So we can say the rim must have a silicone / rubber layer. Okay, so why do you want to have this thing? Is so that it is airtight to prevent leakage of steam. Okay, oh sorry, SPM. Now guys, I ask you a question now. Why pressure cooker can cook faster? Because pressure cooker inside got one advantage. It has high pressure. Oleh itu, it will go higher temperature. So pressure cooker is actually related to gas law. This is actually the Gay-Lussac law. So it is related. Okay. Now, so next, wall of pot must be thicker wall of pot. So why do you need thicker wall of pot? Because to withstand the high pressure inside the pot lah. Kalau tak, it will explode lah. Okay. Lepas tu, okay. A lot of people tell me the lid have hole, the bidi bala. Okay. We can say larger pressure release valve. Pressure release valve, so that the pressure can be released faster before opening the lid. Okay, lagi heat insulating handle. Okay, wait got safer or not? Got safe can. Okay, so don't say heat insulated. Okay, cannot say faster than use shorter time. Same meaning, same one. Shorter time. Okay, can. Now, so next, so leakage of steam will be no leakage of steam, sorry. Say leakage of steam. Handle. Okay, don't straight away say the name of the material. We can say we will use something known as high specific heat capacity. So therefore, it acts as a heat insulator. All right. What else? Base, leakage, lid, rim, wall, metal. Oh, you can also say you must have locks. Okay, so that locks on it, so that you can secure the lid. Meaning to say that okay, because sometimes right, if you see pressure cooker before, they got like those like the tepi got lock, then you can like twist and so on and so forth one. So that is also known as a lock. So it will secure the lid, prevent the lid from popping up. Okay, that is salah satu question also. Okay, Ken. All right, no problem. Okay, next. Okay, I think we can only do like 1.5 question remaining. Now, guys, remember, promise me, I resend this file again. All right, I resend this file again. Make sure that you remember must finish this before your exams. Okay, why? Because you have nothing else to do now. I mean, do you have anything else to do? I don't think so, lah. Okay, can. All right. Now, so okay, without further ado, let's go and see one weird question. Okay, page 28, 28. Okay, here. So this is the image of the fish. So where is the real fish? If this is the image of the fish, where is the real fish? Lower, correct, below. So how do we draw this thing? So step one, okay, let's say I can put the kepala of the fish. So I draw a line to the person eye first, okay, because this is the image, all right? So the light actually enters the eye. Okay, guys, very pantang one. They want this kind of thing one. The light actually enters the eye. Okay, but actually, when you look at the other way around, so this is the water. So this is your 90 degree. This is your so-called your normal line. So where is actually this fish? So this fish is actually now like that, but it's actually somewhere below here. All right, actually somewhere below there. So that's where your fish is. Okay. Now, however, guys, satu problem. Wait, oops. Okay, this is my fish. Okay, what is the problem with this picture? What is the problem with this picture? Correct, very good, Yingxuan. Now, so the answer is the dotted line. Okay, the dotted line. So only to this is my dotted line. So actually the image has to be dotted line actually lah. Yeah. A arrow correct direction when you see the fish is the light enter your fish not going to the fish all right. Should deeper compared to the image of the fish. Okay, can. All right. Now, okay, guys, recently question tukar trend a bit already. Actually, supposing the fish need to be dotted because it's a virtual image. Okay, now, so recently there is a new trend of question. Okay, the new trend of question is like this one. Okay, so korang dengar dulu Okay, they don't like to ask the person to the fish liao. Recent punya trend is they like to ask the point of view of the fish. Hey, Wei Yang, how you know one? Okay, yeah, this is the fish to person. This is the the latest trend. Okay, so not human see fish, is fish see human. Okay, now, so you will see that, okay, this is the fish. Okay, so sekarang where the human is, okay, the human is here. Let's say. So now, okay, masalah adalah how will the person, okay, how will the fish see the person? Okay, so first of all, the light ray now masuk fish right? Kan? So therefore, the person, when the light ray from the person, the fish try to see the person, okay, you need to know how to draw. Yeah, it is actually flying, but you need to agak-agak draw a bit. Okay. So this light ray will actually refract towards normal. So this is what the actual path of the light ray is. Now, it will undergo a autocorrect. Okay, what do you mean by autocorrect? Meaning to say that your eye, the fish eye will thought that he sees a straight line. So therefore, this one will actually form sort of like a straight line. Okay, so this is where the image of the person will be. Okay, guys, remember this is supposed to be straight line lah. Okay, I mean it's supposed to be a straight line. Okay, but because I got no ruler, so you just agak draw it. So the fish will see the human is actually flying. So maybe this is another new trend of question. I don't know. 我不知道. I don't know. 我不知道. Oh yeah, can I? All right. So this one, I think you guys got no problem, right? Okay, if you got no problem, okay, then after that, next, let's just look at another one more small tiny part that I think we are almost done with the day. All right. Remember, guys, finish up this paper. It's not many questions, it's just like 10 or 11 or 12 questions. Okay, all state paper. So all state paper. Maybe you do before. Okay, kita tengok question 11. Okay, you might get something like this. Okay, they ask you the direction of current. Okay, so now they want you to draw the direction of current, the direction of magnetic field, and the direction of force. Okay, I give you 30 seconds to consider this thing because otherwise it will just sound like you are copying answer only, a past special. Okay, so 30 seconds over. Okay, so current. So this is my direction of current. They want you to label flow through the copper rod. So this will flow here. So the copper rod, the current will flow in this direction. Okay, this direction. Lepas tu, the current will flow in this direction. Okay, so that's the direction of the current flow. Oops, hang on. So this is the direction of the current flow. Lepas tu, where's my magnetic field? My magnetic field, I have to draw M. So magnetic field is always north to south, right? So this is your direction of magnetic field. So this is left hand or right hand. Because there is current, my hasil is force. So therefore, left hand. So the magnetic field. Okay, so where will this thing go? So where will this thing go? To the right hand side. So this is your force. This is your force. Okay, Ken? So this is your force. Okay, now next, explain how the force is produced. Okay, explain how the force is produced. Anybody? Yeah, so you have to talk about the catapult field, like the magnetic field becomes stronger, then then it will push the thing and so on. So guys, you must remember, if you don't have the word catapult field, nobody can save you. Or you must have the word catapult field. Okay, now so let's just write this together lah. Okay, why go right? Left hand Fleming rule your magnetic field 向上, your current 离开你, so your 拇指 to the left, to the right. Not your magnetic field, is your current. I think 子轩, 以我了解你是这样子. Your answer is up, correct or not? I guess you get up. Don't know. Okay. You take the gun, shoot your screen, shoot your phone or shoot your screen. Okay. But now your magnetic field is pointing upwards. So this gun now shoot up already. 就是射向上了. Okay. The middle finger must point to your screen. So your magnetic field point up. Your middle finger point to the screen. Macam tu. Okay, I can, alright. No problem. Okay, then lepas tu next. Okay, So explain how the force is being produced. How the force is being produced. So the answer here is, okay, we say that the magnetic field, well guys, don't say you're tired, I'll also be tired right here. We can say that the magnetic field from the permanent magnet, okay, interacts with the magnetic field from the current flowing in the copper wire. Okay, so the magnetic field from the permanent magnet, it interacts with the magnetic field from the current flowing in the, meaning to say that your this north-south magnetic field and your current potential magnetic field interact, okay? So this produces a catapult field, which produces a force to push wire. Alright, can. Okay, to push wire. So macam tu lah. Okay, can. Now guys, for people who attended my class today, y'all got job one. Tomorrow I will post, after exam, I will post something on my Instagram. I need you to react. I want you to vote. How was your trials? Easy or difficult? Okay. Now, I want to know how was your trials? Easy. No, you cannot vote now. Okay. Trust me, a very easy one. Okay. Now guys, so this one talking about how to see the magnet already. So remember, you have to be very good with this about the catapult field thingy. I will post it on my YouTube open. Okay. Yeah. The Sri UCSI gang, y'all make me feel very bad, Like I didn't help you all like that. But it was so easy, right? Your trials. Cursing say very easy lah. So I believe it's very easy. Okay. Now, so okay, next. Okay, we say the next one is a motor. So make sure you guys know how to do motor. Like for example, what stronger magnet, more number of coil, increased current, so 那种 blah 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 stuff 的东西啦. Okay, can. Alright. So make sure you know that also. Alright. Now, thank God cursing not here. Okay, now. Yep. Okay, so therefore, last part for today. Okay, guys, this one is a bit out of sort of like out of the, not in your book, okay? But because got people say teacher can teach this thing or not. So since you guys say takkan I want to tolak you, right? Takkan I want to ban your idea, right? Okay. So okay, they asked me how to do this question for this one. This is a lawnmower. So lawnmower, the more stable angle, size of cutter, blade mass, and length of handle. Okay. So you guys know how to do this or not? Lawnmower. Okay. Can. You want me to discuss this thing? Okay, let's just try. Okay. So first one. How to move the lawnmower? Do you want to push or pull? This is not in your book. Not in your book. Guys, this is not in your book. So you don't have to flip and find or what. It's not in your book. Okay. So in this case, okay, we will do a push lah. Okay, so far so good. Push, the answer is push, not pull. GG. Okay. Now next. What about the angle of theta? Hey, you're better careful. Theta, they refer bottom. If I am your school teacher, I will sure carve out the theta here. Tricky a bit. So this theta is bigger theta or smaller theta? Okay, bigger theta. No, it's not 45 degrees, it's larger. Okay, in fact, you want it to be very vertical. All right, next. Size of cutter blade, you want big or small? Big size of cutter blade. What about the mass of lawn mower? Larger. Why larger? Okay, later we talk about this. Okay. 对， it's the same one. Then what about the length of handle? Then what about length of handle? Shorter, longer. Longer. Okay, the answer longer lah. Okay. So now longer. So now we discuss, we finish this thing, then we can function already. Okay, can. Now, okay, wait, hang on, just give me a moment first. Why do we want to? Okay, because we want to have larger downward component of force. Okay. Or if you don't want your answer to sound very similar, right? You don't want your answer to sound very similar, right? You can do something like this one. No? You can say like, so that the pushing force acts downwards. Like you are trying to tell that when you push, there is a force that will act downwards. Okay, when you push, there's a force that acts downwards. Okay. Now, then after that, angle of theta. Angle of theta will be angle of theta will be larger angle. Okay, this one that I can say higher downward force. Okay, so if you want to explain why do you want higher downward force? Why? So that you can grass can cut shorter. Because it's just like I wish you this example. Let's say I want to shift my 手毛, let's say for example. So let's say I want to okay, imagine this is my ruler, so I'm going right. So the more I press down, the more downward force there is. I can shift my hand more. Faham kan? Correct? So then after that, why you want larger size of cutter blade? Cutter blade, because more grass can be cut at the same time. Meaning to say, like for example, if I say, what is the advantage of if you have a bigger mouth? You can eat more bigger spoon at the same time. So it means that you can eat more as you can eat. Or you can also say reduce time to cut. Okay. Next, why larger mass? Okay, your answer same punya. Larger mass is because you can have more downward force again. Downward force. Because you can say larger mass, so there's a larger weight acting downwards. So I hate to do this kind of essay question because I feel like it's very repetitive. It's just like repeat, then repeat, then repeat, then repeat. Okay, so that's why I say I hate to do this kind of essay question. Very boring. And small mass more portable. Unless they got tell you more portable. Here they want more stable. So in fact, you can also say this one can also increase the stability since they actually say stable. Okay. Then last but not least, you boleh cakap dia punya last punya answer adalah longer length of handle. Longer length of handle. Okay. I don't know you realize this or not, but 不是 cannot is not every single time you should. The word cannot is 讲啊 is wrong, is don't only use the soalan as the answer. See, you understand what I mean? Yeah, okay, can. Now, so longer length means that it will be, you can use lesser force to push lawnmower. Okay. The idea is like what, guys? Can you all know, like, I don't know you all got live in this era or not, but you have to book up the tin of biscuit. You know what's the book up tin of biscuit? Do you know what I'm saying or not? Okay. The Julie biscuit. Wow. What? You're so old one, man. You're so old one, man. Okay. Reduce tension 啊，不可以行为，不可以，那个不是那个重点。Okay. So that thing. Okay. If you use a very short metal versus if you take a longer metal, which one will be easier to book up? Obviously the longer one, right? Correct. Yeah, so therefore that's why. 当然 you also cannot have too 夸张 long there's a limitation also of course then let's say if you want to book out the thing, because also cannot too long alright, can. Faham? Okay, can. Alright. Yep, so far so good. I think everybody doing very well. Okay, so guys, we have already reached the end of 1 o'clock. I need to go to TTC already. So if you guys got any problem or what, you all can refer to my physics Instagram. So I will post this to my YouTube. You can also share this thing to your friends. All right, so you can also share this thing to your friends. I will post around like 3:30, 4 o'clock like that okay, so you can share this to your friends also. Yeah, I wish you guys all the best. I go TTC because I ajak student watch F1. Yeah, so okay. Now, so if you guys got I'm leaving in like 10 minutes, so maybe like 2 o'clock I will arrive okay. So if you guys got no problem, I will sampai sini saja. I'll see you guys next time. Bye bye. Thank you for coming, everybody.